Hello and welcome to another edition of Turbo Delphi Demos. I'm Nick Hodges, the Delphi Product Manager, and I'm here to talk a little bit more today in this version, in this episode, about polymorphism. Polymorphism we talked about in the last demo. And polymorphism is the one, probably most of the three, of the three main pillars of OOP: encapsulation, inheritance, and polymorphism. Polymorphism is the one where you go, why the heck would I want to do that? I don't get it. And so I'm going to try and explain and give an example of sort of why you would want to do that. It's going to be very simple, straightforward, using the same classes that we've used in the last few demos with the classes demos. I'm going to try and show you a little bit about why it is you'd want to do it. Now, in the examples we've got here, we've got, again, a person that of type T person, an employee of type T employee, and then actually now we've added this customer class, and I'm gonna go ahead and enhance this customer class a little bit, and I'm also going to override this class function called full name. I'm going to override it for strings, and I'm going to hit. Let me clean up the spacing here a little bit. And I'm going to hit Control-Shift-C to create a stub function here. And for the sake of argument, I'm just going to override this and say we always want to be very, very polite to our customers. And I'm going to go ahead and be sexist just for the ease of argument here and say we always want to call them Mr. And then we want to call, again, the inherited full name. So I apologize to all the females out there, but I could do this, I guess. And oops, this is an error from the last demo. So now we've got three classes that implement the full name property, each a slightly different way. The person class just creates the name with the first name space last name. Employee, T-employee, creates the full name with associate space first name space last name. And now we've just recently, brand new here, created this new full name. Then we'll put Mr. or Mrs. whatever, some salutation at the beginning, so we can tell the difference, in fact, basically between these three groups, these three types: person, employee, customer, and employee. Okay, so now we've got an employee. I'm going to go ahead. We got T person. I'm going to delete this from the last one, and now I'm going to create customer, T customer, right? So now, okay, I'm going to type a bunch of code here, and so what I'm going to do is I'm going to turn the video off, I'm going to type it, and then I'm going to come back. Okay, we're back, and what I've done is just created some sort of boilerplate code here. I've created an instance of each of the three types of classes that we've declared: a person, an employee, and a customer. And then I've just come in, and actually I forgot to change. Let's see, we'll change the names real quick. I apologize. Fred Flintstone and Mr. Slate. Okay, so now we've got three different people. One's just a regular person, one's an employee, and one's a customer. And now if we run this application, of course, we will note that each of the three full name calls that outlays there does the different thing. Barney Rubble just gives the regular person's name. The employee says associate Fred Flintstone. And then, ironically, we have a Mr. Slate. But you can see that the three different full names were called, obviously, because in this case we've actually explicitly created each one as the type that it is, in keeping with the same exact type of variable that it is. So T person is a T person, employee is a T employee, and customer is a T customer. Now, let's just say, for the sake of argument, that this was sort of a collection of employees and people and different kinds of things, and we wanted to write a letter to all of the customers and to all of our employees. We wanted to do a letter, and for that letter we wanted to one of the things we wanted to do was create the entire salutation line, like Dear Mrs. Johnson or Dear Fred or whatever. So we might create a function like this called create salutation, and we might say, okay, I'll take a T employee IT employee, like so, and I'll output a string. And then the result of the string, result of this function would be something along the lines of, say, dear space, and then the A employee's full name. Now, of course, we're going to have customers too, so we have to do one for the customer, you know. And this is advisedly, just as an aside, this is kind of not the way you really would want to do it, but it's it's illustrative here. And then we want to change this to a customer. I'm just using this to illustrate how and why you'd use polymorphism. So you'd say a customer full name, right? I'm sorry. I would call this employee salutation, and I would call this create customer salutation. And of course, if I wanted to do one for just a plain person that was neither a customer nor an employee, I would have to create person salutation, change this to T person, a, just for the sake of argument here, person and a person, right? And so now I can call each one of these functions for the appropriate type here. So Control C, I can come down and I can say right line, create employee salutation, and just pass in the employee, and then I can create a customer salutation and just pass in the customer here in this case, right, like so. And then I can do the same thing for the person. I can pass that in, and so they should all balance out, opening parens there. So now if I run this, we should see salutations for everybody. Dear, 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 all in front. Well, now, this is kind of cumbersome, isn't it? I mean, you got 3 functions, right? That doesn't really work. That all each do basically the same thing. Well, we can use polymorphism to do what we're doing here. And by using polymorphism, I can create a single function called create salutation. This create salutation, and in fact, it will work for all 3 of these different objects. Since an employee is a person, is a T person, and a customer is a T person, then this function alone, just by passing in T persons, will work for all 3. So now I run this application, and again, we get the proper output, but we've got a single function that can take any T person instance, either an actual T person or an instance of a descendant T person, and that T person will then have its proper class called, or I'm sorry, the proper full name method called. Now, here's an interesting little aside. We'll go ahead and create a descendant class from T customer called T special customer, which will descend directly from T customer, and of course it will inherit all the functionality of T customer, which in turn inherits all the functionality of T person. And so T special customer will indeed have a customer ID, it'll have a first name, last name, address, the whole bit, same as all these others. But in this one, we're just going to leave it, well, you know, we might add some special stuff or some field name, you know, special code for the person, something like that. But we're not going to override full name in this case. We're just going to leave it. So now if I come down and create declare variable special customer, and I come down and I'm going to go ahead and just grab this code here, copy it, and type the word special in front of it, and then, whoops, sorry. And then we'll go ahead and change this to Betty Rubble. She'll be a special customer. You notice again, special customer doesn't have its own full name function, overridden full name function. So you'll see here when we run that it goes ahead and just uses, whoops, did I get rid of the readlin? Whoops, guess what I didn't do? I threw an exception. I didn't create special customer. Sorry about that. That would be a big mistake. Create, and then of course I should free special customer because I've allocated memory. Okay, so now I'll save and run, and you'll see that the special customer, Mrs. Betty Rubble, gets the Mrs. on the front with her full name just like the T customer does. Now, the reason for this is because we have not provided an overridden full name function for T special customer. So when polymorphism begins to work on these classes, it works its way up it looks at the class itself that we're working on and checks to see if it does indeed have a full name property or full name function. And if it does have a full name function, it calls it. If not, it works its way up the inheritance chain looking for the first one. And in this case, it just finds the T customer one and calls that. So we've taken a look at one of the reasons why you would want to use polymorphism, and that is it enables you to create single methods or functions to function that will function on numerous different classes in the proper way for the type of that class. We created a create salutation function, passed in a person, and we noted that if we pass in a person, we get person's full name. If we pass in an employee, we get the employee full name. If we pass in a customer, we get the customer's version of full name via polymorphism. Thus it eases this is one reason why you'd use polymorphism. It eases the need to create specialty functions for each of your types of classes inside of your class hierarchy. So that's a quick look at why you'd use polymorphism, why object-oriented programming is fairly powerful and interesting to use. And that concludes this version of Turbo Delphi Demos. Thanks for listening, and we'll see you next time.